All right, in this session, I try to show you how you can calculate G-multiplier. In a standard case or general case as this one, we had this Keynesian problem in a previous video session. I'm going to actually continue on that and drive G-multiplier from it. And then after that, I'm going to show you in a different case, a different setup of Keynesian model, how you can drive G-multiplier in case of balanced budget, means that government expenditure is equal to net tax revenue. But let's first focus on this problem, G-multiplier in general case. In this case, we can use this equilibrium condition where national output is equal to planned expenditure, including these items. So I just rewrite this equilibrium condition here, but I substitute C with consumption function here. So 150 0.75 times y minus t. Instead of t, I can replace t with its function here, so it's minus 0.4y. The reason is that I don't want to have this t, I want to have y. Then we have investment here. The amount of investment is 683. I just put 683 here. And then export is before export, maybe I should consider G. I let G be as it is, because to calculate G-multiplier, you want to have y as a function of G. So you don't insert the number G here. You just let the G letter stay in the formula. But plus X, which is export 691, and import is a function of y. You just put the function here. Actually we don't need this for a while, just put it aside. And here we have a simple, well, I don't know if it is simple for everybody, but it's an equation. We want to simplify it first, and then we want to isolate y, all terms with y to the left. So I start with 150, multiply through this, time y, and multiplying this by this is first plus time minus is minus, then 0.75 time 0.4 is 0.3 y. So I get rid of this parenthesis and have these two terms instead. Then again 683 plus G plus 691 plus 0.12y. Now I want to organize these numbers. So I write the left-hand side y equal to, first I add up all these constants. I can just write it first as it is, 150 plus 683 plus 691. Then I would like to add together all terms including y, and to do that, as I have done in my previous videos, you first add up all these coefficients, these numbers attached to the y. So 0.75 minus 0.3, sorry, this is minus 0.12. I just change it to minus. And these terms have a common factor, which is y. You just put it right here. So if you look at the terms on the right hand side, we have considered all of them but g. So we just put plus g at the end here. Sorry. Now you can add these up and these. So we simplify the expression even more. This adds up to 1524. And this adds up to 0.33. So what we have here is 1524 plus 0.33 y plus g. All right. Now we want to move that to the left of this equation. And if you add both sides, subtract both sides with this. Y. And here 0.33y. So you will have on the left hand side this y minus 0.33y equal to 1524, and plus 0.33y minus 0.33y is 0, so you don't need to write anything here. You just jump to next term, which is g. Now I have all terms with y on the left hand side here, and the common factor between these two terms are y, and then from this you have 1, and from this you have minus 0.33. So if I want to get rid of this parenthesis on the left hand side, I can divide through all terms with exactly this amount, because when I do that, this amount divided by the same amount makes 1, so you just can write y here is time 1. You don't need to write the 1 here. So you get rid of these terms, factors, Then on the right hand side we can write 1524 divided by maybe should write it here so you can see it more clearly. Not what I'm doing. I can write it this way also. It's the same meaning, like this. Well, here y is a function of g, and you can take well, the definition of multiplier, what is it? Is dy dg, means the small difference in or change in y that comes from small change in g. All right, and this is actually the derivative of this. So this is the definition of G-multiplier. At the same time as it is the first difference of this function. So I just rewrite it as the differential notation, and the differential of this function with respect to g, this term is 0 because is constant, so nothing here, and then the derivative of this with respect to g is equal to 1 minus 1 divided by 1 minus 0.33. And that is actually our G-multiplier in this case. And this is actually the marginal propensity to consume out of domestic production. And just for curiosity, you can see that you can always find this marginal propensity for consumption of domestic products. That's equal to marginal propensity to consume overall times 1 minus marginal propensity for tax, which is in this case, if I put this back, is equal to 0.4. And this is 0.75. Let's carry out here. So this term minus marginal propensity to import, and that comes from here. So if you do this calculation, 1 minus and minus this, so your marginal propensity to consume domestically will be equal to 0.33. So this is another way, if you don't want to do this differential calculation, you could find this marginal propensity to consume domestically through this formula, and when you have this, you just put it in this formula for multiplier, so you get your multiplier. All right. Now I would like to go through the other problem that I showed you here, and that is G-multiplier in the case where we make sure that the budget is balanced. Means that taxes is equal to government expenditure. Tax revenues equal to government expenditure. Again, we can use the same equilibrium condition as before. Means national output equal to planned expenditure. Plus export minus import. And in this setup we use a different consumption function and import function. Your tax is not a function, it's fixed, equal to government expenditure. But since we are going to drive the G-multiplier, when we, well, the condition for balance budget is that G equal to T. So this is the condition. So I go on here and insert the consumption function instead of C here. 100 plus 0.7 y. Here minus T. I don't put T here because I won't have a function of y, a function between y and g. So instead of T, I put G because they are equal. This is the key actually to drive G-multiplier in case of balanced budget. So you replace T with G because they are equal anyway. The next item here is investment. You could put the number here, 20. And then it is G. You don't replace it with this number because we want it as a function. So you put G here. And then next is X, which is export. We have here 180. And then import minus import is 0.2 y. So you see that this equation includes y and g. And we are going to write y as a function of g. Then we can drive our multiplier. So now I don't need this one. I need to do some algebra here. 100 plus, I multiply through this, 0.7y plus time minus is minus 0.7 g plus 20 plus g plus 180 minus 0.2 y. Now again, what I do is to add up all these constants. I can see that 180 plus 20 is 200 plus 100 is 300. So I just put it here. Then I can add up terms including y. Is 0.7 plus minus 0.2, so it's plus 0.5 y. Then I have these two terms to take care of. 1g minus 0.7g. It makes plus 0.3g. Yeah, it's nice and clean equation. The only thing is that I want this term with y move to the left, so minus 0.7y on both sides. Minus 0.5y minus 0.y5. So I just can move this equal sign a little bit to the right because I need space here. So here the common factor is y, and 1 from here and minus from here, 0.5, minus 0.5. Here I have 300, and these two cancel out each other, so I don't have any term with y on the right hand side. Instead I have plus 0.3g here. So if I want keep only y here, no coefficient, I divide all terms with this factor. So I will have this equation. Point 3 divided by 1 minus 0.5 g. So now this is the function y, a function of g. And the definition of the multiplier is, of course, this dy dg, which is the derivative of y with respect to g. The derivative of y with respect to g, we don't have g here, so it's a constant. It has zero derivative, so it's 0 here. Next, actually I don't need to have this, is the coefficient of this. The derivative of y with respect to this term is 0.31 minus 0.5, and that's actually 0.5, so 0.3 divided by 0.5 is the same as 0.6, and this is the multiplier when we have balanced budget. Now if you want to go on and see the impact of a change in G, change in G on Y, you can use this multiplier. So let's say you increase G with 10, then Y will increase with times the multiplier. here, well, that's the change in y. So change in y is equal to 10 times 0.6, means actually 6. So if you increase government expenditure with 10 and at the same time you increase tax revenue with 10 so that you have the balanced budget, the national output will increase with 6. Thank you very much.